this video, we're going to see how to determine if a given vector is a linear combination of some other vectors. So here I've written down a question: is the vector 3, 4, 3 a linear combination of these other three vectors? So our first step is to unpack this definition of what it means to be a linear combination. So what we're saying here is that there's some scalars, maybe there's x1, x2, and x3, that we can multiply them by these three vectors, 2, 1, negative 1, plus maybe an x2 times 3, 1, 4, and maybe an x3 times 7, 0, 3. And we want to know if we can produce the vector 3, 4, 3 out of those other three vectors via addition and scalar multiplication by some scalars x1, x2, and x3. So what we're really asking here is, does this vector equation have a solution? If it does, then we're able to build the vector 3, 4, 3 out of the other three, and if not, then we're unable to. All right, so we have a vector equation that we want to solve. So we can think about this as a system of equations. So in which case we'll want to write down an augmented matrix representing this system and compute its reduced row echelon form, just like we're solving an E3 problem. So the matrix we're interested in here, so 2, 1, negative 1, 3, 1, 4, 7, 0, 3, and we're trying to produce the vector 3, 4, 3. So this augmented matrix here corresponds exactly with our vector equation above. So we'll go ahead and compute our reduced row echelon form. So we'll type that in our favorite calculator. I went ahead and did this via Wolfram Alpha, and this produced the following matrix. All right, so now that we have the reduced row echelon form, we can write down the corresponding system of equations for the reduced row echelon form, and we can then determine if we have solutions or not. So in particular, our first equation says x1 is 2, our second equation says x2 is 2, and our third equation says x3 is negative 1. So not only do we have a solution, we have a unique solution, right? So the only scalars that work for this are 2, 2, and negative 1 respectively. So this means the answer to our question in blue here is yes, this system does have a solution. So yes, this vector 3, 4, 3 is a linear combination of those other three vectors. In particular, it's 2 times the first one plus 2 times the second one plus negative 1 times the third one.